So the next topic, moving on to the example for the exponential distribution. Hope it is visible. Okay, here is a table generation of exponential variate generation table is given here, where 5 different random numbers are taken. Its equivalent xi value, ri value as well as xi value which is given, and it is also given that the lambda value, frequency, the mean value is given as 1. Okay, just go through the statement of the example. So we can calculate the inverse transform as follows. Okay, using the formula you can go through the things. Graph, it is written, graph contents are given, just go through it once. Just substitute the values ri or r1 in general, which is equal to 1 minus e to the power minus lambda x. What is the value of lambda? Value of lambda is given as 1, the mean value which is given as 1. Okay, I'll just highlight it. You watch my previous video for the formula and all. Formula contents we have discussed already. Ri which is equal to, isn't it, or r in general, which is equal to 1 minus, right, e to the power minus lambda x is, that is what the thing we have considered. So lambda value is 1, that's why it will become minus x. Since r1 we are computing, it will become minus x1, isn't it? Whereas x1, we can write x1 which is equal to, actually x1 which is equal to value of x is what, minus 1 by lambda into log to the base e, that is ln of 1 minus r, isn't it? So minus 1 by lambda, just observe here what will happen. Substitute value for lambda. What is the value of lambda? Lambda value is 1, that's why minus 1 by 1 you will get. So minus remains, which you can see here. If you want, I'll highlight. Okay, so minus ln remains into 1 minus r1 as it is. If you remember the formula easily, you can substitute the contents over here. Okay, in general the relation is written as this is from the thesis directly, r equal to f of x, or r1 equal to f of x1 in general, and x1 which is equal to inverse. X1 will become the inverse value. As you can see, x1 equal to f inverse of r1, that's it. Okay, the values and calculation part which is there, no need to worry about that. You just go through the graph, you will come to know. Okay, so graph is plotted for f of x for the various values. Actually we have to even refer to the appendix part. Let us discuss this briefly once again once the classes are resumed. So you just go through it once, statement. If you know the formula, easily you can substitute them and you can compute the values. Okay, moving on to the next topic, that is uniform distribution, another kind. So we are talking about the random variate generation. So for random variate generation, in that inverse transformation technique or inverse transform technique we are speaking. So in that inverse transformation we have exponential distribution, then uniform distribution, Weibull distribution, triangular distribution, and so on. The second type, the first one we have discussed already. The second type is the uniform distribution. So in the uniform distribution, consider a random variable. Once again, let us denote it as x, that is uniformly distributed in the interval. So interval value is given as let a and b are the interval values. A reasonable guess for generating the random variable, that is x, is given as follows as per the uniform distribution. So this is the formula as per the uniform distribution. X equal to a plus b minus a into r, a plus b minus a into r. Okay, where x is a random variable generation within the range of value a and b. What is the range? See here, interval value is given as a b, so it can be given as per the uniform distribution function, the x value, random variable value, which is equal to a plus b minus a into r. Okay, where r is always a random number. Please remember, r is a random number which lies between 0 and 1. The probability density function for x, that is small f of x, can be given for the uniform distribution. Probability density function, or PDF, for the uniform distribution, which is equal to, see here, this is b minus a. Okay, b is not visible, so 1 by b minus a. That is in normal case, where x lies between a and b, as you are aware of the interval value. is between a and b, so x lies between a and b. So what will happen? F of x value equal to 1 by b minus a in normal case, that is for x lies between a and b, otherwise it will become 0. Okay, this is what probability density function or PDF. Then CDF, cumulative distribution function, that is the CDF for this particular uniform distribution. CDF can be given as capital F of x, which, okay, see here, in normal case where x lies between a and b, it is x minus a by b minus a, sorry, x minus a divided by b minus a for the value x lies between a and b. If its value is 0, if value of a is value of x is less than a, if the value of x is greater than b, then its value is 1. Please remember the cumulative distribution function for the thing what we are discussing, the uniform distribution, which is equal to 0 for x less than a and 1 for x greater than b, because a and b are the intervals we are considering. In normal case, its value is x minus a divided by b minus a, where x lies between a and b. Just go through the things what you have, what is highlighted over here. Okay, then next step. So it has got this function has got only 3 steps. Earlier in the previous exponential distribution has got 4 steps for computation. This has got 3 steps. The first step is cumulative distribution function finding of CDF. Then second step is setting up of the value f of x, capital F of x, that is CDF, cumulative distribution function, which is equal to, see here, x minus a divided by b minus a in normal case. Normal case value is taken, which is equal to r. Okay, which is equal to r. What is r? As you can see, earlier we have noted that term, right, where r is always a random number, lies between 0 and 1. It is applicable throughout. Okay, it's a random number, and it value ranges between 0 and 1. So f of x, the cumulative distribution function or CDF, which is equal to the random number r. What is the value of CDF? X minus a divided by b minus a. That is what step number 2 is. And third step, so solving for x in terms of r, which yields x equal to, so just separate x, you will come to know. Okay, this is just a simplification. X equal to, you will get a plus b minus a into r. Okay, this is after simplification you are getting, which is same as the equation 8.5. This is 8.5, as you can see, x equal to a plus b minus a into r. Directly you just have to remember the equation with respect to different kind of functions, distribution functions. Now we are talking about the uniform distribution. Earlier we have discussed about the exponential. Now we are speaking about the uniform. Next will be the Weibull distribution, then triangular distribution, and so on. 4 to 5 different types we are supposed to discuss. Okay, please try to remember the formulas and all. If you have any doubt, you ask. Let us discuss about the examples once again once the classes are resumed. Watch the video again. Please note down the things. This is very important. Straightforward question you can expect from here.